All right, there, ladies and germs. I left you with a pretty tough question today, and it was formed a little bit differently in every hour. So we have to kind of acknowledge that what you're about to see is kind of like the straight down the middle best version of what I can show you. So here goes nothing. So we have this idea that if you're going to show us a reflection, two things have to be true. So let me try to record what I'm thinking here. So if I want to show something's a reflection, wow, let's just try that again. If I want to show something's a reflection, two things have to be true. One, I have to show that distance is the same. And when I'm talking distance, I'm talking, wow, so many loops of that end. I'm talking from the center of rotation to the point. Whether that be the image point or the pre-image point, the distance has to be the same in either one. In the same way, like radii to a circle are the same. In fact, a circle had a lot to do with the thinking today. The second thing that I have to show is present is the angle of reflection, or I'm sorry, angle of rotation, formed between the two radii. So in other words, if I think that A, or I want to show that A has been rotated to A prime, 90 degrees about the center of rotation C, the two things I absolutely have to show are true is that these two distances are the same, and also that, which I can show, excuse me, by kind of thinking about those being on the same circle centered at C, and the other part is it has to be a 90-degree angle. Okay, so that's where we are in class. So now I'm trying to destroy the prototype. I'm trying to say, well, if that is really what's going on, we have to test it out to the most obnoxious level. So what we did, well, the challenge I left you with was, well, consider two situations. That's how a point works. But how does multiple points work? How does like a triangle work? So you have kind of two options in how this might actually play out. So option one, we have a, I'm going to put the grid on here, and I'll just do like the upper half plane. So option one, you have point, 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 which would be like A prime, B prime, and C prime. And then if you want to do a rotation around the center, you have to acknowledge that you need the angle and you need these distances. So the way that this could be accomplished is that you have a line going to the center of rotation, which will bounce off, so to speak, at a 90-degree angle, the same exact length, and that's how you're going to find A prime. And then now if you want to go to B, and again, this is just an option, okay? If you want to go to B, you're basically going to do the same thing. Actually, let me move B just slightly because it's going to overlap and it'll confuse things a bit. Let's put B right here. Anyway, so you're going to do the same thing for B. You're going to bring a line down, parallel this time. You're going to bounce it off the same distance. And again, this is a non-to-scale drawing, so please don't freak out on me. Yeah, the distances aren't perfect. B prime. And then you'll do the same thing for C, which I will do in orange. You bring a line straight down, bounce it off, same distance. And that's your C prime. And then now you can compare your two triangles, ABC and ABC, okay? Not to scale, but that's one version of how you could use or how you could reflect more than one point, in this case a triangle, okay? And there's lots of validity here that might actually be true. Like, for example, I can see that this distance, and I'll highlight it, I can see that this distance BC is consistent because as I slide this down, you'll see kind of went with it. I can see that distance is the same throughout that whole process. Not necessarily something I can see with the other version. I can also still observe that there are 90-degree angles present. It's 1, 2, 3, and all the distances, no matter purple, green, or 1, 2, 3, 1, 2, 3, purple, green, or orange are still the same. So I'm not violating any of these rules necessarily. The distance is still the same, and so is the angle of rotation. Because I still see the consistent distance, orange and orange, green and green, purple and purple, and I still see that 90-degree angle right schmear. Okay, so that's option one. Maybe that's how it works. Now there was another option. I said that weird option. There was another option option 2, as it were. Okay, and option 2 said that instead of moving around my center of rotation, because I end up having 3 centers of rotation on the left, I'm going to keep the same center of rotation no matter what. That's my center of rotation. So if I look at that same triangle, same-ish triangle, whoop, iPad slipped. Here's A, here's B, here's C. I'm going to do basically the same thing, but instead of shifting around my center of rotation, I'm going to keep my center of rotation the same. So there's 90. Those are meant to be the same distance. So there's my A prime. Let's go purple. So purple, purple. There's my 90. There's my B prime. And then for C, boom, 90-degree angle. So it would be right there. There's my C prime. And then you can kind of see the triangle that results. So the question is, which one is this? Which one makes most sense? Do they both make sense? Is one better than the other? Is one blatantly wrong? So what it really boils down to is that do I have to keep the same center of rotation for the object? Or can I move the center of rotation around? Because in both cases, I'm keeping the same distance from C to the center to C prime, A to the center to A prime, B to the center to B prime, and I'm also keeping the same 90-degree angle every time. So that neither one actually violate this rule, okay, where the distance has to be the same and the angle of rotation is present, but both cannot be the way you form you form a rotation. So which one is it? That's what you guys have to decide. That's what you need to bring in next time you see me. A's tomorrow, of course. B's and B classes on Monday. So you have plenty of time to think about it. Bring in a good answer, or else. No, just kidding. Bring in a good answer. I'll see you guys later.